Welcome to today's webinar brought to you by Materialize, NetApp by Instacluster, Synadia, and Informatica. I'm Stephen Fegg, Director of Database Trends and Applications in Unisphere Research. I will be your host for today's broadcast. Our presentation today is titled Building a Microservices Architecture for the Edge and AI Era. Before we begin, I want to explain how you can be a part of this broadcast. There will be a question and answer session. If you have a question during the presentation, just type it into the question box provided and click on the submit button. We're going to get to as many questions as possible later. Now, to introduce our speakers for today, we're very excited to have with us Josh Ehrenberg, Field Engineer at Materialize, Anil Inamdar, Head of Professional Services at NetApp, Jean-Noel Mouan, Field CTO at Synadia, and Abhalash Mullah, Senior Manager, Product Management, Data Integration at Informatica. Each speaker today is going to give a brief presentation, and then we're going to dive into a group discussion. So, without further ado, I'm going to pass the event over to our first speaker today to get us started. Welcome to the broadcast, Josh.
Thanks, Stephen. Really appreciate it. Hi, everybody. I'm Josh Ehrenberg, and I work on the field engineering team here at Materialize. And for those that may not have heard of us, Materialize is an operational data store with the mission to empower businesses to act confidently on fast-changing data. And today I'm here to talk to you about how you can use Materialize as a data integration platform to simplify your microservices architecture. First, a quick bit about our company. We were founded in 2019. And our founders and leaders have an extensive background and expertise in databases and streaming from Cockroach Labs, Microsoft Research, Apache Flink, and Confluent. And Materialize is built on top of an award-winning technology known as differential data flow. Our co-founder, Frank McSherry, published a paper around this computational model, which provides a way to incrementally maintain results with sub-second latency while delivering strong consistency. So we've built a data store on top of this streaming engine that lets you handle fast-changing data at low latencies, incrementally update the data, and serve those updated views to the users. So with that, let's get to today's topic, which is microservices. Specifically, I want to talk about how we can coordinate and consistently join data across your microservice databases without breaking encapsulation. Over a decade ago, the microservice architecture emerged as a way to solve a key challenge, and that's allowing multiple development teams to work in parallel without deployment bottlenecks inherent in monolithic systems. And by trading the speed of in-process function calls for the flexibility of loosely coupled services communicating over networks, often via the REST protocol, microservices enable the teams to operate functionally independently, iterate quickly, and keep implementation internals private. This approach has proven effective, which can be seen by its continued popularity 10 years later, but it comes with a limitation as it has been practiced, and that is that there's no good way to support complex queries on data that spans multiple microservices without breaking the encapsulation that gives the architecture all its benefit. So in a standard microservice architecture, each service uses its own database local to the service. As you can see here in the before picture, this has the great property of encapsulating the service, meaning the team responsible for that service is free to make changes. They can deploy, change the data model, the logic, and as long as the API continues to be stable, everything is fine. But the problem comes when questions arrive that require data from multiple services. So consider a delivery service in a typical e-commerce app. The service might rely on data from the customer service, the inventory service, perhaps some others, and any aggregated reporting on deliveries would require consistent joins across all these local databases. In our standard microservice architecture, this all needs to be handled in the application tier, generating complex and error-prone bespoke logic between the services. And it's often slow because it requires multiple calls to multiple services across the network to piece together all the transactions necessary. So often, consistency and transaction safety are an afterthought. And what ends up happening in practice a lot of the time is that the service teams give up and they break encapsulation and just start calling each other's databases directly. But now, we've just given up on a bunch of the advantages of this architecture, and we're sort of restitching together a monolith without the benefit of forethought and pre-planning. So our architecture is slowly accumulating coupling, our schemas are becoming rigid again, et cetera, et cetera. So Materialize can solve these problems. By connecting our microservices private databases in real time and tracking their operations and transactions via change data capture, we have a platform to support complex queries, query reads, including joins, across these databases in a way that doesn't lock our teams into an implementation or iteration schedule. So each team can maintain their own data product on the Materialize platform that users can query, join, or stream from as they see fit. This layer of indirection keeps the individual teams in control of their implementation and deployment schedule while giving their users a stable interface in the data layer that can build their own data products and logic against. And we call this approach the operational data mesh, which borrows the term data mesh from the analytics space, but certainly not limited to data analytics in this use. Like Materialize is a platform for real-time data integration. And because it's real-time, it means that we can use it for operational use cases. We can point applications at it and so forth. So that's great, but let's look at what Materialize actually is. Materialize emerged as an operational data store, as an approach for handling real-time workloads. When we looked at the existing solutions for handling complex queries against fresh data, they really fell into three categories, right? One was abusing the transaction store, so either through read replicas or directly against the databases, right? Which gives us the property of having fresh data, which we need, but slow queries because the data is arranged for transactions. It's not arranged for aggregation. And so we end up with fresh data with slow queries. Cloud data warehouses have also emerged to solve this problem. They have the opposite property. They're arranged very well for analytic type of queries, but the data is stale because usually there is a ETL pipeline. And so, we're not dealing with data that's recent enough to be used in the operational space. And then the third option that many go for is the roll your own option. And this could encompass anything from, streaming frameworks like Flink or, rolling your own microservices, which probably happens a lot, especially on the edge. And the problem here is that anytime we want to change any of our views, any of our queries against the data, this is typically a development problem. So we run into talent bottlenecks. We run into bespoke development teams to solve these problems. And, if we just need people getting answers from this data, this can be a real bottleneck. So Materialize emerged. What we want here are OLAP queries on OLTP data without compromising the trustworthiness of the results. So these three principles: freshness, fast queries, and consistency, where consistency would be observing the transactions of the upstream data store, right? And having our data tie out, right? And no matter where that data resides. So if it's in this case where it's multiple microservice databases, or maybe it's being fed into Kafka, maybe it's coming, via other sources, Salesforce, Fivetran, that sort of thing. And with the team and the budget that we have. So this is where SQL comes in. Materialize can be used by your existing data team. You don't need a developer to use it. It's 100% PostgreSQL. So Materialize is a real-time data integration platform that enables you to transform, deliver, and act on fast-changing data just using SQL. And allows you to tie your microservice architecture together in a way that you can use in the operational space. Some other common use cases that we see are sort of real-time customer 360, live portfolio integration in the finance space, online fraud detection and rule-based alerting. But there are tons of examples of where we need to be able to act on complex queries on fast-changing data, on live operational data. So that's where Materialize comes in. Thank you very much, and look forward to your questions. And with that, I'm going to pass it over to Jean-Noel for the next presentation.
Thank you. So, hi, my name is Jean-Noel. I'm field CTO at Synedia. I'm here to talk to you about NATS for microservices and edge and AI. NATS is, if you don't know about it, nats.io, it's an open source connective messaging system. It started its life over 10 years ago as a purely messaging PubSub system. Since then, has evolved to have a lot of other functionalities besides queuing microservices, also the ability to store data and behave, and so therefore provide you streaming, such as you get out of something like a Kafka, for example, but also going beyond that into providing NoSQL interface as well. It is something that essentially you use to simplify your software stack, because you can use it to do publish, subscribe, queuing, request, reply, and microservices, streaming, as again you would do it in the Kafka-like things, object store, and also executing workloads at the edge now with the Synedia NATS execution engine. Sorry. So the idea is that it is something you can use to build your applications on, build distributed application, microservices, and so on. And you can really simplify a lot your stack by, rather than having instances of Kafka, Redis, something like its CIO or Service Mesh, something like S3 or MQ, and all these you can replace with a single thing, which comes in the form of a single binary of 15 megabytes in size, so very small, very something you can actually deploy at the edge directly. That gives you all that functionality. So in a prospect of, for example, doing microservices on top of NATS, what it gives you is distributed queuing with geo-affinity, meaning that client application publish requests, and those requests are automatically distributed for fault tolerance and scalability purposes over however many instances of the service that you may deploy. Because NATS is a system that has a lot of flexibility in terms of the deployment models that you can have, including all the way to the edge. It also has the concept of geo-affinity, meaning that if requests are, a client is connected to a particular cluster or a particular edge cluster and makes a request for a service, if there is instances of that service within that cluster, that's where they're going to go. They're going to stay and be processed locally rather than being sent to another cluster somewhere else over the internet. So you can do request reply, request many. You have also the ability to do CQRS type of request reply, where you put the request into a queue where it stays there and gets processed, and the reply goes into another queue to get there. That gives you decoupling of temporal decoupling of the requesters, clients, and services, meaning that the client can publish the request even if the service is not up at that time. The service comes up later, picks up the request, and then so on, right? You also have the ability, because it is based on top of a messaging system, it's all using subject-based addressing in the sense that you can find in publish subscribe systems. What that means specifically is that two things. When you make requests, you just publish to a subject. So you do not need to have all this stuff like having, for example, DNS entries that update themselves to tell Others, when you make, REST API, for example, you need a DNS to know where the IP address and the port is for the service you're trying to invoke. There's a number of them, so you need to also have load balancers, you need to have proxies, reverse proxies, you need to do service discovery. You may need to deploy something with like for example, an NCIO with sidecars to provide observability. All this disappears and you don't have to worry about it with NATS, because you simply publish to subjects no matter where you are. And observability is, because it's publish subscribe, is as simple as being able to subscribe and listen to those requests as they happen in real time. So basically you have the functionality, most of the functionality that you'd normally have out of a service mesh, but all that plus messaging, plus NoSQL, plus streaming in one single 15 megabyte Go binary, which has no external dependencies, that runs pretty much everywhere, from a large server on a cloud to your desktop, a laptop, to as far as small as something like a Raspberry Pi running at the edge, right? Because it is that small. One of the really also differentiators of NATS compared to other messaging systems you have in there is, as I mentioned, the ability to have a very wide flexibility in terms of topology, and including be able to deploy with something we call the leaf node, which is the same server, the same binary, everything. You can deploy at the edge, and that allows you to have, like, for example, a hub, which is a cluster, or it could be a set of clusters. You could have a cluster per region. You could have clusters that span different cloud providers. You can have clusters that are in the cloud, clusters that are on-prem, and also clusters or single servers that you deploy at the edge. And where this is really interesting in terms of IoT and edge is because these servers, we have the ability built in to do what I call real guaranteed store and forward replication of data between the edge cluster and other clusters, be it the hub cluster, the cloud cluster, even if that edge is partially connected. That means that if the edge is, for example, a device on a vehicle that moves around and is connected to the internet over cell phone network, or maybe it's a robot on a warehouse file which connected over Wi-Fi, and as it moves, it keeps coming and going out of connection. You don't have to worry about this. It takes care of storing temporarily as long as needed the messages, and replicate them as safely and guaranteedly back to the hub. So what does it mean also about AI, and specifically about AI at the edge, right? One very good use case that we see customers use NATS for at the edge with AI is running inference. So AI at the edge basically is, to me, means that you are able nowadays to run inference engine directly at the edge. Now, the inference engine, you're going to have to feed it sensor data, video frames, a lot of data that you feed to your inference engine, and the inference engine is going to reason on that and detect anomalies or threats. Opportunities and threats, right? So you end up with having two flow of traffic. One, which is the, I would call it low value, high velocity flow of traffic, like those video frames that you feed the inference engine. And the other one, which are high value but low velocity events, which is once you have identified that threat or opportunity, you want the ability to send that reliably. You don't want to lose it to the hub. While otherwise, if you are for the other type of things like video frames, if you lose a video frame, you can always wait 10 milliseconds, there's another one. So using NATS deployed at the edge with those leaf nodes allows you to really, as a developer of an AI system, only worry about your model, your inference, everything like that. You do not have to worry about the infrastructure of being able to deal with the transport locally within the edge, and also safely and guaranteed having the transport back of those events back to the hub. And then finally, quickly, what about Synedia? So Synedia is the company behind NATS. We are our CEO is Derek Gleason, the guy who created NATS in the first place. And we are the home of all the maintainers of the nats.io, open source system, which is a CNCF project, by the way. and provide self-hosted, managed software as a service version of NATS. And on that, I will pass it on to the next presenter. Thank you.
All right. Thanks, John. Hi, everyone. Good morning, good afternoon, wherever you're joining from. My name is Abhilash Mula. I'm part of the product management team here at Informatica. And for those who are not familiar with Informatica, we do all things data, whether you're doing data integration, data engineering, AI engineering, data governance, MDM. We do all things data, and I'll kind of cover more in detail on some of the services and products that we have around data. So before we dive into the specific of microservices for AI and edge use cases, let's take a step back and look at the foundation of what makes all of these things possible, right? So the foundation is basically cloud computing. The shift from monolithic architectures to microservices is not happening in isolation. It's being driven by cloud native technologies that provide the flexibility, scalability, and resilience needed for modern AI driven workloads. Cloud services, whether it's infrastructure as a service, platform as a service, or software as a service, they all play a critical role in enabling decentralized deployments, AI model hosting, real-time processing, and event-driven applications at the edge. Now, in the following slides, let's explore how these cloud layers map to microservices architectures and why they are important for AI and edge computing. So in the previous slide, we have established how cloud computing serves as a foundation, right? Now let's dive into some of the complexities companies are facing in terms of modern data and applications. So many organizations today are facing massive data fragmentation with thousands of applications. There are variety of data stores, and every system has varying data latency requirements, and it makes it challenging to integrate all of these systems and leverage the data effectively for AI driven insights. With 149 zettabytes of data growing at 40% per year, many companies are struggling to manage structured and unstructured data across different data stores, whether it's relational or vector or file based storage systems. Meanwhile, AI and microservices architectures depend on seamless data integration, real-time processing, and scalable infrastructure to drive intelligent decision making. Now, without a strong data foundation, AI models lack the quality inputs needed for accurate insights, and real-time applications also will fail to deliver timely responses. So that's why, as we move forward, we'll explore how modern microservice architectures address these challenges by leveraging cloud native solutions, AI driven automation, and event driven data strategies. Now, so far in the last two slides, we have discussed about the massive data challenges that companies are facing today, right? So, to name them, there's data silos, there's exploding data volumes, variety of data structures. Now, what this slide is showing you is how a modern data architecture is very important to overcome some of these challenges for powering microservices at the edge with AI. Now, this architecture kind of acts like a central data hub, integrating variety of data sources and preparing that data for action. The data lakehouse, for example, handles massive volumes, and it can store a variety of data structures. Paradigms like ETL, ELT can manage can process different data at different speeds. We are also seeing an emergence of newer data stores like vector databases, which is very critical for many AI applications, right? So especially for microservices at the edge, this architecture enables decentralized data access and processing. It provides clean integrated data that AI models need. It supports real-time, batch, and event-driven architectures that are very important for edge applications. Basically, to summarize in short, right, this modern data architecture is the foundation for successful microservice deployment at the edge, enabling real-time intelligent applications that we are going to discuss, that we are discussing in this webinar. Now, so far we have discussed the data challenges and the need for modern data architecture. Now, what I want to introduce is Informatica's data platform, which is Informatica's Intelligent Data Management Cloud, or in short, we call it as IDMC. It is a unified platform that is designed to tackle some of the challenges I described in the previous slide. What the platform does is it enables seamless data integration, data engineering, ensuring there's data quality and observability, and provides governance, privacy, and security to your data. And these are all some of the capabilities very important for AI driven decision making. With app and API and app integration, we facilitate smooth data flow across many microservices, and services like MDM and 360 applications. You can create a single trusted view of data. And the entire platform IDMC is powered by Claire, which is nothing but Informatica's AI engine that can automate a lot of key processes, improving efficiency and scalability. Whether you are dealing with data sets that are sitting on-prem or cloud, or you're dealing with hybrid environments, Informatica Cloud Platform has the flexibility to deploy architectures wherever your data is located. Now, let's look at the mega trend that is changing and affecting everything, right? So AI or generative AI. I mean, this topic by itself needs a much broader and separate deep dive, but I'll try to provide as much details as I can, right? So at Informatica, we have two initiatives. One is what we call as AI for data management, and there is a data management for AI. And I'll cover both of these topics in the next following slides in detail. Now, before I get to the details of what is get into the details of AI for data management and data management for AI, let me set the context, right? So what this slide is showing is the priorities that many companies have. As you can see on this slide, it's clear that the major trend many companies that are prioritizing is AI, right? But successful AI depends on the quality of data, the security of the data, and how fast you can access the data. As you can see on the slide, the number one strategic objective is AI for many companies. But AI models are only as good as the data that they rely on. Without high quality or governed data, all your AI initiatives will struggle to deliver meaningful results. Data quality is one of the very important feature, and as you can see, many companies are prioritizing data quality. Ensuring trusted, well-structured data is a top focus for everyone, particularly for enterprises dealing with complex environments. And as AI adoption grows, the concerns around compliance, governance, and also data protection is also equally important. That's why, as you can see, that's number 3 priority for many organizations. And organizations must build, like companies, if you're building AI applications, it has to be built on the foundation of very secure and compliant data. And that's why, as you can see, that's one of the strategic objectives for many companies. Now, let me get into the details of what is AI for data integration and data integration for AI. Let me start with AI for data integration. So this is what Informatica has built on years of AI and ML innovation that we have done around the metadata intelligence layer of our product stack. And I'll talk about what this means, right? So so recently what we did is we have released two main products. One is called DI Copilot, which is being released this quarter, and there's also we have our own GPT, what we call as a Clear GPT, that is available, that has been available for over a year now, right? So what these two products does is it allows users to explore data, no matter whether it's structured or unstructured data, or whatever system it's locating in. Clear allows us to explore the data, prepare the data, and also automate building this data integration pipelines with natural language prompts. You don't need to know Python or complex. You don't have to do any coding. Using natural language prompts, we can build complex data pipelines using our AI-powered platform. And we think by doing this, it will foster democratization of data, and thereby, companies can make more improved decision. And what does it mean for data engineers? I mean, as a data integration company, a lot of data engineers use our products. What it means is we are increasing the productivity of the data engineers so they can solve more advanced use cases faster, right? So that's one of the thing that we are doing at Informatica using AI. Now, how does it relate to microservices, right? So especially for your edge deployments, what CLAIRE means is faster integration with your edge data sources, simplified data pipeline development for your microservices, and improved collaboration across various teams, whether you're a data scientist or business analyst. You can, by using IDMC or using CLAIRE, you can improve that collaboration. Now, let me briefly talk about AI for data integration. So what AI for data integration means is how Informatica is enabling companies to implement their AI pipelines, what is also known as AI engineering, right? So typically in AI engineering involves like two critical steps. One is extracting and loading large volume of data. It can be structured, unstructured data. And especially with AI applications, we are also dealing with newer type of data stores, graph databases, vector databases. And in the process, as you are processing these data stores, you need specialized transformation techniques, right? Like, when you're dealing with large unstructured data, you need things like chunking the data, or embedding generating embeddings, which is nothing but embeddings nothing but basically generates numerical tokens or references known as vectors that describe your chunk of data. And once the data is loaded into your vector databases, then there's a AI query or a prompt, right, or a chatbot that you use, right, some sort of a AI application. So this process goes through another pipeline that is, one way to call it as is a RAG pipeline, right, or retrieval augmented generation. Simply put, what RAG does is it generates an AI response by interacting with large language models or small language models and blending the data with your enterprise data or vectors or tokens that are created in the first step, right? Now, I mean, I may have oversimplified by explaining only two steps, but there are a lot more steps involved in the AI implementation. But these are the two fundamental steps for any AI implementation, right? One is processing your data and then building some sort of an AI application where you can consume that data, right? And Informatica is helping the data engineers to do AI engineering as well by providing capabilities like chunking, embedding, calling LLMs, and we are also creating newer connectors to vector stores or graph databases. So, so far what we did is we talked about the need for solid foundation for our microservices, and that's exactly what this slide is showing. Again, I'm kind of going back to the slide I already showed, which is our IDMC platform. Now, think of this platform as a central hub for all your data needs, right? This platform is not just for technical people, but we got tools for everyone, whether you are a data engineer building pipelines for business users, or data analysts, you can use this platform. And with AI, we are empowering any user using natural language, right? You don't have to need special coding skills here. We have data integration as one of the core services that can connect to different sources, whether it's IoT devices, local databases, I mean, you name it. We have like over lot of connectors that can connect to any system that's out there. And then there's API integration so that your microservices can actually talk to each other and other apps in real time. Data quality is built into the platform because we know bad data means bad decisions, especially when you are working with generative AI applications. Security and governance is also covered, which is also super important when we're dealing with sensitive data. Basically, to summarize, IDMC or our Informatica Intelligent Data Management Cloud is the complete package for managing your data for your microservice, managing your data at the edge, making sure your microservices have the data or the fuel they need to be more smart and effective. With that, I'll pass it on back to Stephen. Thank you, everyone.
Thank you very much, and thank you everyone for those fantastic presentations. So we're going to get everyone up on the screen here and dive into our group discussion. Josh, I'm going to let you be our leadoff batter here. The first question for today: what is the number one challenge organizations face when building a microservices architecture for the edge and AI era?
Yeah, sure. Thanks, Steve. I have a certain viewpoint on this, given that we're, a data platform. But I think, one of the biggest challenges is around data silos, and that's because, when you're pushing things out to the edge, even more so than with a traditional microservice architecture, right? You have lots of little data stores. If you're doing a database at the edge, maybe you're doing RocksDB or something like that out on the device. There are still going to be questions that you need to answer by aggregating that data. And Materialize, as a data platform, can make it very simple to pull multiple databases into one place where they can be queried. And we also offer something called a subscription. And what that is a long-lived connection that can let you push events out. So what you could do is, if you have a whole bunch of services out at the edge, they're all returning data, and then you need to aggregate that data to decide what your next action is going to be, or to trigger actions out at the edge. That subscription connection can allow you to do that in an event-based way.
Understood. That's interesting. Jean-Noel, what do you view as the top challenge? Do you agree, or do you have something else in mind?
There's so many challenges, to be fair. This is more challenges than anything else. I think, there's definitely the ability to store data at the edge, and also to distribute data at the edge is really key. As I said, as you deploy things now, we can really push AI to the edge, except gathering data that you then ship to the cloud, for example, for training, right? It's really all about running the inference at that level. And as I said, inference can take, the whole point of it is you can take a lot of data in quickly. Those be video frames, those be sensors, where, for example, customers, they have sensors on machines that detect the vibrations, right? Constantly feed that to a local little box system, right? That can then detect, that one is vibrating too much. It's about to break, right? And that event goes up to cloud, raises an alert. This is very, very powerful for those people. The same, we have those, not yet AI, but it will be AI yet. There's vehicle manufacturers that have those NAT servers in a cloud, but also in every single vehicle. There's actually, we joke amongst us, and we see when a vehicle of that brand go drive down the street, I was like, oh, look, there's a NAT server driving down the street. But it is used within a vehicle for all the different, ECUs to communicate together, and also to send, again, the important stuff to the cloud or from the cloud. It could be events to, say, pre-warm the car. Or now imagine the same thing now with AI models, right? You can do that, and you can also, I didn't mention that, but use NATs, the same that guaranteed store and forward, right? Can be used to, for example, have a model stored in the cloud as you update your model constantly, right? You update that value there, and it automatically will get replicated and pushed down to all your edge devices if they happen to be connected at that time. That happens in real time. If they happen to be out of signal for a while, then as soon as they get back into signal, they automatically get it there. So it's also interesting to, as I said, the AI, the model it's progressing all the time, right? We're still very much in a state of discovering how far it can go. And as you also probably know, in AI, the more data you have to feed your model to train it, the more accurate your model goes. So it goes to say, without saying, people start using AI, they have a certain amount of data to do the initial training. But the important part is they're going to want to keep feeding that data to keep training that model to be more and more accurate. That also means you want to update in real time constantly that model to the edge where it's going to be running. And that's the type of things that people use NATs for in this context.
Understood, and great points. And I personally love that car feature for pre-warming. It's very cold here in New Jersey right now. Apalash, where do you land on this question? Hey, Apalash, can you hear us? Can you hear me?
I can hear you. Yeah, you're fine.
Oh, okay. I think
It's not you.
Apalash lost audio. Apalash, can you hear us? All right, we'll give him a second. So, Jean Noel, I'm going to let you lead with our next question. What technologies should every organization have under their belt to succeed here?
I mean, asking me, obviously, a messaging, streaming, no SQL data store middleware is really important and interesting. And to go back to Josh's point, what Materialize does, state, right, is when you're talking about microservices, right? And especially nowadays when you have pods, right, and you want to be able to use stuff like container aggregations, like Kubernetes, whatever, to easily scale up and down, right, provide you an elasticity of your service instance. When you do that, you want your pods to be stateless, right? So that means that you need to store that state somewhere where all the pods can get it. And it needs to be for state. Specifically, there's two things that people use Nats for storing state is the KV feature, right? Because a lot of state, you don't necessarily need to. It's a different problem that what Josh talking about. In this case of state, you often just need to do a get per key. You don't need to do complex queries or aggregation or joins, something like that. But it needs to be super fast. You're talking measured in microseconds. And also the other aspect, which is because NATS is at its core initially a proper pub sub messaging system that can push events to the endpoint. The KV naturally is not just put, get, take, it's also watch, meaning that you can create like a continuous query on a KV saying, give me as they change or as they get inserted, all the new update, the new puts that happen on this. And that means that allows you, because state is something that's always in flux. And when you're doing microservices and you want to coordinate the services together, you want to be able to push that state as it changes, right? So for example, I don't know if you know K3S, right? It uses something called Kine, which is a layer on top of what would be otherwise could be TCD or things like that, right? There's a version now with that which embeds NATS KV as the KV to store in there. And exactly for that very reason of state is something that changes very quickly. So you want to be able to update it very fast, right? You want to be able to just get, but you also want to be able to have pushed updates of when that state changed so you can react and update your processing context as it happens.
Understood. Apalash, good to have you back. I'm going to throw a twofer at you. So I think you probably heard the first question, which, in your opinion, what is the top challenge here? But as a follow-up as well, that you can weigh in on, what technologies are critical for this? Obviously, an opportunity to talk about yours, but, broader than that as well,
Absolutely. Thanks, Stephen. I kind of agree with Josh was describing with data silos. So I think the primary challenge is, especially in the data silos, is ensuring there is seamless data integration, even with the data silos, right? Because especially with microservices architecture, data is distributed across many systems, and that seamless data integration is very important. And especially when you are dealing with real-time data for AI applications, and microservices also often require different services to communicate with each other, but maintaining consistency or managing large-scale data flows and handling the latency between many systems, right? When you're dealing with these complex systems like the architecture I showed you with the broader landscape, right? Handling so many systems and integrating them for AI to perform faster is always challenging, handling those data sets. And to your other question on what technologies should companies use or have under their belt to succeed. I think John Knoll has kind of described containerization. He kind of touched on Docker and Kubernetes. I think those tools will help deploy and manage microservices at scale, so that they are portable, scalable, and resilient, right? And especially when you're dealing with data-driven applications, a strong data integration platform like Informatica is needed. So that way you can streamline the movement of data across different system, ensuring that data is ready for AI processing, and then also data remains synchronized across different microservices.
Understood. Thank you, Apalash. Josh, we're back to you, and I'm going to let you answer, but I want to throw this in as well. We got a question from one of our attendees that is directly relevant to you. The question is for you. OLAP queries on OLTP data traditionally are fraught with performance sacrifices. Are you certain that from Materialize, your approach and solutioning overcomes this? So I was hoping you could weigh in on that as well.
Yeah, but terrific question. And yes, I think the key point that about Materialize that allows us to handle these types of complex queries over top of transactional data is the incremental nature of the engine. So in other words, what they've built is a very capable query engine, but what it's doing under the covers, it's taking a Postgres style view, right? You're writing a SQL view. It's decomposing it into something that can be handled by timely data flow, by this streaming system in an incremental way. So that's what allows it to be performant, is that we're only acting on the changing data. And so, the asterisk there is that to get the best performance out of the system, you have to, you write these queries ahead of time, and then they're maintained over time, rather than say, hey, let me, do all the work at query time. And that's, I think, what allows us to get the really good query performance. In terms, and for the other question, one thing that occurs to me, and this is, I'm going to go completely outside of Materialize here and just say, like, I think, the key technology to get your hands around is around change control, right? Especially when you have things distributed out to the edge, right? How do you manage releasing new versions? Changes to the logic, changes to the system become more complex. And so really having stories around things like blue-green deployments and things like that, how do you manage state out at the edge? All of that becomes critical.
That's a great point. Apalash, I'm going to let you lead off on this next question. How can organizations do a better job of managing latency and ensuring real-time processing for AI workloads at the edge?
Yeah, I'm going to give a very generic answer without going specifically into Informatica products, right? So to manage latency effectively, I think companies should focus on things like real-time data pipelines using technologies like Kafka or Flink to ensure that data is continuously ingested, processed, and acted upon without any delays. So we are it's not a near real time, but real time, right? Also, local processing, deploying lightweight AI models or edge processing frameworks that allow data to be processed closer to where the source data is located. So that way you can minimize the whole, round trip of communication across, centralized systems, right? That's also one of the, most critical thing to maintain kind of low latency for real-time processing. And specifically coming to AI, we need to ensure AI models are optimized. Example, they should go through the process of, pruning so that they can process the data faster and reduce the compute requirements as well, right? So basically, we need to keep an eye on the cost as well. So, obviously, Informatica has the right tools and in place to solve all of this, but real-time data pipelines, local data processing, efficient model deployment when it comes to AI, FinOps, applying FinOps principles is very critical.
I'm glad you brought up costs because that's certainly on the radar of a lot of companies out there. Jean-Noel, curious for your views on this.
Oh yeah, I mean, what he said is music to my ears because it's exactly what we are doing. In terms of, streaming processing, right? If you put a messaging with distributed storage, you have streaming, right? The messages are pushed up to where they need to be at all times in literally matters of milliseconds or lower, right? Depending on the network, obviously, right? Again, there's no substitute in terms of latency to running your model inference at the edge directly. Otherwise, you have to. It's not just time, but also cost, right? If you have to send a lot of data over the network to somewhere else to get processed, so you get back your threat and opportunity markers, that's slow. That uses a lot of bandwidth. You're probably gonna pay for this, right? And then again, having the ability to have the local state, right? Be it state that you use for processing, for lookup, for that state I was talking before, or that state could be looked at as a model. The ability to have very easily, so you don't have to worry about it, right? This ability to say, I'm just putting the data here. Let's say I'm updating the model in my data store at the hub, right? And magically, whenever they're connected or not, everyone gets it, right? And they're gonna get it. And conversely, those events coming from the edge back up there. And so that you don't have to worry. This is hard stuff to do. I mean, we've been at it for 13 years and we're still fixing bugs type of thing. And asking a developer to have to worry about, okay, so if I want to send it to the hub, okay, I need to try to establish a TCP connection. Oh, it's not working right now. So I need to store it and try later. Oh, but I also need to persist it to disk because at the edge, you may run out of battery at any time, right? It's not just disconnection, but you can literally pull the plug, run out of battery, and this happens all the time. So you can store it just in memory. You need to store it on disk. So when it comes back, you have to say, okay, let me see what I have stored on disk, and let me see if I can connect now to that guy, and then send it to him, and then get back an acknowledgement, make sure he really got it and was able to process it. All that stuff. And then on top of it, you also say, oh, I want that KV as well, and I want that super fast, low latency, reliable, not guaranteed, just plain reliable for my video feeds, for my sensor events and things like that. Having all that, you don't have to worry and reinvent that wheel is a huge benefit, I think, for AI developers. So you could concentrate on implementing your business logic, concentrate on tuning and working on your model. Don't want to have to deal with that infrastructure. It's painful to do it right.
All fantastic points, and I would have to agree. Josh, this question seems up your alley. Curious for your thoughts.
Yeah, for sure. And I agree with a lot of the things that have been said so far. This idea of being able to run the model out of the edge makes a lot of sense. And I think, where we come into contact with this stuff is typically there needs to be some kind of combination between like what's happening with the local state, but also, companies tend to have all of their data these days is in relational databases. So oftentimes, like, if you're looking at a strategy like RAG, for example, where you're trying to, inject customer context into the inference, at query time, this is where, having some way to build a view on top of relational data that can be handed in, at that time, and something that can be subscribed to so that these things can be pushed down, and combined with the local state or the larger state that's happening out at the edge.
Understood. I know I promised earlier we'd keep this to an hour, and I'm going to try to do that. But of course, I see like we're almost at the top of the hour. We have great attendance today. I want to end this with one more question for each of you. Lightning round. What trend are you most excited about? And if you would like our viewers, if there's one thing you would like our viewers today to walk away keeping in mind, what would that be? And Jean-Noel, why don't we start with you? You know what? I think you may still be on mute, Jean.
Sorry, sorry, my bad. I cough a lot. I
No
try to
problem.
mute myself. Um, I'm really always impressed by all the ways you're going to be able to use models and inference. That's one thing that's really to me, one of the best part of my job working with this technology is there's no end of amazement of the ways people can find ways to use it. People come to us and saying, we're doing this with that, we're doing that with that. Like I said, there are companies that are doing this feeding of the sensor data to inference engine. That is happening today in many places. There's people using it for controlling and discussing with robots that roam big, vast warehouses. There's stuff using it on trains, on planes, on drilling platforms, satellites, even, right? Drones. I've heard all of this. It's really a good time to be watching all the stuff that you can now do at the edge, right? And to be fair, one of the most exciting part is simply your phone, right? That is such a powerful computer nowadays. With all the GPUs in there, we're just, I think, barely scratching the surface of all the stuff we're going to be able to do AI at the edge, right? The edge is your phone, is in your pocket. You are the edge, right? And lots of exciting possibilities are coming online, and it's quite exciting for that.
That's a great point, and I'm glad you brought up phones. Sometimes we kind of lose sight of them when we talk about edge use cases, but everyone's got them. They're ubiquitous, and they're close to us. They're at us at all times. Abhilash, I'm going to let you go next. It's a trend you're most excited about, and if there's one thing you'd like our attendees today to walk away thinking about, what would that be?
Yeah, I mean, like John Al said, we are just scratching the surface of AI, but I'm specifically around AI. I'm particularly excited about the rise of AI agents and all this autonomous decision making systems. We saw AI models recently, like doing reasoning. So yeah, specifically around AI agents and autonomous decision making systems. I'm particularly excited about those because these are driving. These AI driven agents are making real time decisions based on the data, and they are evolving, which is like a big game changer, right? Because data is going into the systems and they are making decisions in real time. Another thing, exciting trend is the development of this full self-driving system, the FSD systems. It's just not just for vehicles, but also for various organized operational and business processes as well, right? Where AI models are autonomously handling complex decision making, and these systems are leveraging data on the edge, or doing real time data integration. And AI is just becoming more smarter and making decisions faster for us. So I think we are just pushing the boundaries of how businesses can operate with higher efficiency and intelligence using generative AI. So yeah, I'm excited
It's
about this.
exciting. Yeah,
Yeah.
it's exciting. Buckle up. It's going to get wild. Josh, last but certainly not least, your take. I'm going to give you the final word.
All right, thank you. And I'm going to go in a completely different direction with this question, and say the thing that I'm excited about that maybe don't seem as exciting is the sort of the rise of data products. And as a practitioner, right, and especially talking about microservices, this is where like the world of data is kind of moving into the world of microservices, and like having data become something that is part of the product team, that is supported as sort of a first-class citizen, as a thing that gets all of the care and attention that your applications API might get. And I think this really comes into a lot of these conversations around AI, around like how do we really manage the handoff of data to these autonomous agents, to these things. Like we've got to get serious about supporting data as a first-class citizen. And like I'm starting to see kind of the walls fall away from like what is application data to what is analytic data. It's all kind of becoming one thing, and it all needs to be sort of a first-class a citizen and something that's supported, as such, as the products of our teams. So that's my answer.
That's a great point. After all, AI runs on data, lots and lots of it. So I would like to give a huge thank you to our speakers today for coming on board and sharing their insights and expertise. Once again, Josh Ehrenberg, field engineer at Materialize, Jean-Noel Moine, field CTO at Synadia, and Abhilash Mullah, senior manager, product management, data integration at Informatica. So if you in attendance would like to review this presentation or share it with a colleague, we've made it easy. You can use the exact same URL that you used today. This will be archived and you will receive an email once the archive is posted. And if you would like a PDF of the deck, you can go to the handout section once the archive is live. Thank you, everyone, for joining us today, and we hope to see you again soon.
Thank you.
Thank you, Stephen. Bye-bye.